Welcome to the first segment of the Septic System Series presentations on septic tanks. Have you ever thought where all your household water goes? How do we protect our environment? How do we protect ourselves? In this segment, we will look at how wastewater from a home in a rural area is safely treated and returned to the groundwater system to make readily available water for drinking, bathing, cleaning, and watering the lawn and gardens. Construction, where larger city sewage systems are not available, typically use septic tanks to store and separate wastes. The septic system slowly uses a natural biological filter bed in either a trench or mound system to break down additional waste before returning the water to the groundwater system. This particular septic tank has a 1,200-gallon capacity, making it the right size for a 4-bedroom home in this community. These drawing views provide detailed information about this specific septic tank. Take a moment to study the plans and then select Continue to proceed. Looking at the cross-section view, you can see that this tank has 2 chambers with home wastewater entering from the left and leaving the second smaller chamber to the right. Within the tank, physical separation occurs. The purpose of the left or first chamber is to allow solids to settle to the bottom and oils and fats to rise to the top. The baffle directs cleaner water from the middle zone of the left chamber to the right chamber, where additional settling occurs by density, and then the water leaves past another baffle through the outlet and filter to a mound or trench system for biological breakdown. The manhole covers on top the tank are used for inspection and cleanout purposes. These tanks need to be pumped out every 2 to 3 years to remove the solids that have accumulated. This septic tank has failed and needs to be replaced. It currently is not outputting waste to the trench system for biological breakdown. Opening this 1960s septic tank, you can see that it was built with cinder block construction, not the concrete solid vault construction of today. You can see that this tank was a single chamber. The outlet is mostly clogged, and there is groundwater leaking in, and likely, at lower levels, wastewater leaking out into the ground, potentially polluting the water being consumed in the home. Therefore, the old tank needs to be removed. Breaking apart and removing the old tank is easy due to the huge mechanical advantage created by the hydraulic system of this backhoe. Exposing the house sewer pipe is necessary to make sure it is intact, not clogged, and able to be connected to the new septic tank. Emptying tank debris and preparing the house outlet pipe is necessary as they prepare to install the new tank. Adding gravel to the tank pit creates an area below the tank with drainage of infiltrating groundwater and allows for the tank to be leveled in the ground. This truck not only uses the mechanical advantage of hydraulics, but also a block and tackle pulley system to lift the tank from the truck. And lower the tank into the hole. Adding butyl sealant to the top of the tank allows for a complete seal once the cover is placed on. Similarly, the butyl sealant is used to securely seal the risers that will be covered by the manhole lids. Here, the outlet pipe will need to be inserted. The outlet pipe leads the wastewater to either the trench or mound system for biological breakdown. Congratulations on completing the septic tank learning experience. You are now ready to continue by either viewing the trench or mound system components.